Hello and welcome to this CodeRage 2019 mini-series on how to use DataSnap to build a multi-tier solution from the ground up. My name is Mannarino and I'm one of the Embarcadero software consultants. This session will focus on how to use DataSnap to build multi-tier solutions from the ground up. Delphi and/or C++ Builder has 3 different wizards in the DataSnap category to create new server projects. This video will focus on the DataSnap Web Broker Application Wizard to generate the DataSnap Web Server project. We will discuss the main components and units created by the DataSnap Wizard, such as the DataSnap Server component, the Server Container unit, and the Server Methods unit. We'll cover how to implement the DataSnap Server functionality, and we will show how to create both VCL and multi-device DataSnap clients to connect to our remote DataSnap servers. And lastly, we'll discuss use cases for using DataSnap and some other interesting features of DataSnap. With Delphi and/or C++ Builder, you have different choices for backend technologies to build scalable, fault-tolerant backends on premises or in the cloud. Your 3 main backend technology choices using Delphi and/or C++ Builder are Web Broker, DataSnap, or RAD Server. Of these 3, Web Broker is the most simple and generic web server development framework in Delphi and/or C++ Builder. Web Broker is the underlying technology for many of the web service types that you can build with Delphi and/or C++ Builder, such as SOAP, XML, web services, and DataSnap. For example, using the new Web Broker App Wizard, you can create a new web server app and you can implement HTTP server functionality. Now, Web Broker is good for simple HTTP server functionality, but the more complex the system you want to build, the more you want to look into Delphi or C++ Builder's multi-tier frameworks such as DataSnap or RAD Server. DataSnap or RAD Server provide more higher level functionality than you can find in Web Broker. Let's now look at a demonstration on how to use DataSnap to build a multi-tier solution from the ground up. So here I'm using the current RAD Studio 10.3.3. When you open the New Items dialog in Delphi or C++ Builder, there are 3 different wizards in the DataSnap category to create new server projects. The first wizard, the DataSnap REST Application Wizard, creates a project that is a starting point for building an AJAX-enabled web application. This DataSnap REST Application Wizard generates the DataSnap Web Server project, including web pages and JavaScript files to invoke server methods. This DataSnap Server Wizard supports creating the old-style DBX-based DataSnap servers. And lastly, this DataSnap Web Broker Application Wizard generates the DataSnap Server app hosted in a Web Broker web server. The second choice is the wizard for a DataSnap server. This DataSnap Server Wizard provides an easy way to implement a server application using the DataSnap technology. And the third choice is the wizard for the DataSnap Web Broker application. Now, this DataSnap Web Broker Application Wizard provides an easy way to implement a server application using both the Web Broker and the DataSnap technologies. The Web Broker technology is used to send the server response in HTML format. For me, for building DataSnap backends for applications, this DataSnap Web Broker Application Wizard is the most useful. So let's run through this DataSnap Web Broker Application Wizard to build a server and a client project to understand what are the different parts of a DataSnap framework. We select the DataSnap Web Application Wizard and we click OK. On the first page of the wizard, we can select the platform for the application to be created. By default, Windows is selected for us, and since RAD Studio 10.2, we introduced Linux target platform support. So let's also check the option to add Linux support. And by checking the Linux support, we can now create an application for both Windows and Linux simultaneously. Click Next. On the second page of the wizard, we can select the type of DataSnap Web Broker project to create. So here we have two options: a standalone console application or an Apache dynamic link module. The standalone console application will create a standalone web broker console application web server that has a text-only user interface. It supports HTTP using an INDI HTTP server component. The Apache dynamic link module option creates an Apache module with support for both HTTP and HTTPS. And for Linux deployments with this Apache module, only Apache version 2.4 is supported. So with the DataSnap Web Broker Project Wizard, you can choose to create an Apache dynamic link module to host dynamic or static websites. But for our DataSnap server, let's use a standalone console application. Click Next. On the third page of the wizard, we can specify the port number that will be used by the web application to listen for client requests. And if you are not sure what open port to use, you can click on the Find Open Port button, and the IDE will provide us with an open port for us to use. But in my case, I'm going to try to use port 8080, and clicking on the Test Port button verifies for us that this test port succeeded and we can use port 8080 for our application. Click Next. Now here on the fourth page of the wizard, we can choose which features will be added to our new project. For example, authentication and authorization. We can create some sample server methods. We can add filters for encryption and compression. We can add mobile connectors, and we can also add server module. So for our server, we will create some sample server methods that we can use to test our server. Click Next. On this page of the wizard, we will have to choose the ancestor class for the server methods class. Now for simple projects where we do not plan to use non-visual components in server implementation, we could have chosen T component, but in most cases it is best to choose a T data module. And the last choice, the T dataset server module. This is a specialized DBX specific data module with support for building old style client server database apps using the App Server interface from the Midas era. So in our case, we are going to use a T data module. The T data module will provide us a design surface for dropping non-visual components. Click on Finish, and the wizard generates for us the complete project. Let's click on Save All, and we will save all the default names for all of the new units. So we have our web module unit, our server constants unit, our server methods unit, and we'll give the project the name of CodeRage 2019. Now the heart of the DataSnap server application is the DS server component that you can find in the web module unit. It has the auto start property that is set to true. So at the moment that the application starts, it starts to wait for incoming requests from clients. The server methods unit holds the APIs of the server. All public and published methods declared in this class are callable by clients. The DS server class component in the web module unit connects to the DS server component with the server methods class. So it has the server property that points to the DS server, and it also has the onGetClass event that tells the DS Server components what the server class type is. Notice that in this following code in the web module unit, we are assigning the class and not the object reference. Next, we get to implement the DataSnap server functionality. Now within DataSnap, a Delphi or C++ Builder developer does not write code to instantiate a server methods class inside the server app. The lifecycle property of the DS server class component controls the lifecycle of the server class. By default, it is set to session, which means that for every connected client, there is one server methods class instance inside the server app. When the client connects, it is created, and when the client disconnects, it is destroyed. Now, if this lifecycle property was set to server, then there is only one single server class instance for all of the connected clients. In this case, the server method implementation should be thread safe because its methods could be called from different threads. Now, the most scalable lifecycle option is invocation. So in this scenario, the server methods class is instantiated just for the duration of the server method call. It does not maintain a state across the server method calls. But for our DataSnap server, we are going to set the lifecycle property to the default value of session. Next, let's look at how to build client applications for our DataSnap server. So for now, we'll keep the server project as it is, and let's build a client application for it. Now, the proxy generator will require access to the running DataSnap server. So we'll save all, and we'll click the Run button to start the DataSnap server. We will enter Start in the console window to start the server and keep the server running. Now note, you can optionally enter the server URL in a web browser to verify that it listens on the port 8080 that we specified in the wizard. So now our DataSnap server is running. Next, let's create a new project for our DataSnap client. So in our project manager, right-click on the project group and we'll add a new project. So we'll make it a Delphi multi-device application, blank application. I saved the main form unit with the name uForm DataSnap Client, and I saved the project name as my DataSnap Client, and I changed the name property of the main form to be Form DS Client. Next, we'll use a wizard to generate the DataSnap client code. Let's use our new items icon, and under Delphi DataSnap, we will be using the DataSnap REST Client Module Wizard. On the first screen of the wizard, we will select Remote Server as the server location, and at the end, our multi-device DataSnap client will be accessing a remote server. Click Next. On the second screen of the wizard, we can specify the DataSnap server project type. So currently we are building the client app against the standalone DataSnap web broker server, but in production we will most likely be using the DataSnap server built as an Apache module and deployed to a Linux machine, or as an Izapi DLL running in Microsoft IIS server. So at this point it's okay to select the Do Not Know where the application is going to be deployed, and we'll click Next. On this last screen of the wizard, we need to enter the URL of the DataSnap server and test if the connection can be established. Because if the wizard cannot find the DataSnap server, it will not be able to generate the DataSnap client code. So for our host name, I will enter localhost 127.0.0.1, and for the port, we are using port 8080 as our port number. Now we can click Test Connection to verify that we can connect to our DataSnap server. And now we can click Finish. The wizard generates two new units and added them to the client project. They are the client classes unit and the client module unit. So let's click the Save All button to save these two new units. The client module unit and the client classes unit. The client classes unit is the actual DataSnap proxy code. In this file, you will find the tServer methods client class generated. It has the same name as the server methods class, but with the word client appended to it. It inherits from the TDS admin REST client class and has the same method declarations as the server. The second file generated is the client module unit. And this is a data module with the DS REST connection component already added. It has the host and the port properties already entered for us. And if we right click on the DS REST connection component and click test connection, we can verify that the DataSnap server is still running. So that's great. Now the DS REST connection component also has a second option called Generate DataSnap Client Classes. Now this is very useful when we want to regenerate client classes with the proxy generator. And that needs to be done every time we are adding or changing server methods declarations. The wizard has added the private fServer methods client field in the client module class and added the get server methods client method that is creating the tServer methods client instance, passing to its constructor the REST connection component and returning a ready-to-use class. Now in our client application code, if we want to invoke any method of the remote DataSnap server, we can just call the corresponding method on the tServer methods client class returned from the get server methods client, and our call will be forwarded to our remote DataSnap server for execution, and the result received from the server will be returned. Now if a remote method throws an exception, then it is intercepted on the DataSnap server and re-raised on the client side. Let's now go to the main form of our client app, and we are going to add the client module unit to the users clauses in the implementation part of this unit. So I'll use File, Use Unit, the client module unit to the implementation section. Now on the main form of our client app, I dropped the T button and I dropped a T-edit on the form. For the button on click event handler, I just need to add one line of code that will take the text from the edit box and send it to the DataSnap reverse string method and display in the edit the reversed version of the original string. Okay, so we'll set the text of the edit box equal to, using my client module, call its server methods, call the reverse string function on the DataSnap server, and pass in the value of the text in the edit box. Alright, so that should do it. So now let's run our client app and see how it works. So here's our DataSnap client app running. When we click on the reverse button, we see that the original text from the edit got reversed from the reverse string function on the DataSnap server. And if I click on the button again, it will reverse the string back again, and wishing you all happy holidays from CodeRage 2019. So all of that worked great. And that is all that is involved on how to use DataSnap to build a multi-tier solution from the ground up. Hope you enjoyed it. Lastly, let's discuss when to use DataSnap. Now, DataSnap is a very powerful and rich framework. It is a very good choice for implementing systems with a relatively small amount of concurrent clients. It also supports authentication and authorization where access to certain server classes or methods can be restricted to a certain group of users. DataSnap also has support for communication filters where you can provide custom modifications to the raw stream of bytes that are exchanged between clients and servers. Plus, out of the box with DataSnap, there are compression and encryption filters available, but it is also possible to implement a custom filter yourself. Another interesting feature of DataSnap is the callback functionality. Servers can notify selected or all connected client applications by sending information to callback channels that something interesting happened on the server. And DataSnap also has the FireDAC JSON reflection framework that simplifies building client-server database applications. For example, data from multiple FireDAC datasets on the server can be combined into one object and sent to the client to be loaded into a local FireDAC memory table component for processing. So all changes to the data made on the client can be sent in one operation to the server for updating the underlying database. And lastly, DataSnap is a feature of enterprise and higher versions of Delphi and/or C++ Builder. For more information, there are many online and DocWiki resources, samples, and tutorials on how to create applications using DataSnap. In particular, take a look at the DataSnap Labs web link. This link has a series of step-by-step instructional tutorials that guide you to a deeper understanding of the powerful DataSnap technologies. The tutorials will give you a solid foundation on the knowledge of what you can create using DataSnap, including creating multi-threaded server applications that are capable of servicing concurrent clients and listening on multiple communication ports simultaneously. The RAD Studio DocWiki gives a wonderful DataSnap overview and architecture discussion, including links for tutorials for creating different types of DataSnap applications. And lastly, my blog post for this CodeRage session will have the tutorial steps I used to create the DataSnap web broker server and client applications I just showed in this session. So thank you all for attending this CodeRage 2019 mini session on how to use DataSnap to build a multi-tier solution from the ground up. Regards to all and have a great day.